Good day. We are looking at chemical bonding, and we're moving from Lewis structures to something called VSEPR. So Lewis structures give us clues about the shapes of molecules and complex ions, as it says there. But there's a problem. Lewis structures are simply two-dimensional, like on a flat page. But molecules are three-dimensional. They have depth. And this means we often get misleading structures. We don't get the right angles or the correct angles between the bonds and molecules. So we get misleading shapes. So we have a catchy thing called VSEPR. V for valence, S for shell, E for electron, P for pair, and R repulsion, and theory for theory. So now we're going to come up with a three-dimensional way of representing molecules which are three-dimensional. So it's simply more accurate. What this means is electron pairs can get farther away from each other around the central atom. And if they can get farther away, they minimize repulsion. And if they minimize electron-electron pair repulsions, we end up with a more stable molecule and therefore more accurate. So you've encountered these before. We have lone pairs of electrons. So those are electrons in a central atom that come in pairs, but they're not bonded to any other atom. So they're held very tightly because there's no other atom tugging them away. And lone pairs can distort the shape of a molecule. And the other type would be bonding pairs of electrons, so we can have single, double, and triple bonds. And that means we're looking at the electrons in between two different atoms. And that means they're going to be shared, either polar covalent or covalent typically, because we're looking usually at molecules of nonmetals. And since there's another element tugging on the electrons, the bonding pairs are not held as tightly to the central atom. So VSEPR says, hey, let's minimize these electron pair repulsions, and really, if we have a choice, let's really minimize the lone pair repulsions, because those are the strongest. So we have a process for determining molecular shape. And that means you have to remember how to properly do Lewis structures. And that means for a complex ion or for a molecule. Then you have to determine the A and the X and the E. And we're going to tell you what those things mean. A is a central atom, and that means you only look at one central atom at a time in a molecule. So even if you have a molecule that has more than one central atom, you would just look at one central atom at a time to get the shape around that one. X means atoms bonded directly to the central atom. So we don't care about any other atoms, only ones that are bonded directly to the central atom that we symbolize with an A. And E are lone pairs. So you do all that Lewis structure. You've actually got to go and draw it out, determine A will always be 1, but X, how many atoms are bonded to the central atom, and how many lone pairs are left in the central atom. If you can get that far, then you go to a chart, and it will have all these different types of A's, X's, and E's, and you can write down the name of the shape, and then you can draw it fairly accurately. So your next round of notes will be in a booklet. I'm going to be doing the notes in PowerPoint form, but they tie perfectly into the booklet. So we'll stop there.